Hey guys, welcome back to the Ignite SAT Mastery course. Today we'll be covering Lesson 6 of Module 5, Angle Operations. Now, just as a refresher, what are these angle operations questions? Now, they're going to look a little something like these questions. They're going to mention the words degrees explicitly, talk about arc, and mention angles, again, specifically within the question. In 36, we see angles, and 36 also mentions a minor arc. Word 8, mentions the measure in degrees, and it also mentions degrees there. Now we know these both relate to angles because angle is explicitly mentioned, and 8, an exterior angle, is mentioned. Now, let's try answering some of these angle questions. Let's start with A. The measure A in degrees of an exterior angle of a regular polygon is related to the number of sides n of the polygon by the formula above. If the measure of an exterior angle of a regular polygon is greater than 50 degrees, what is the greatest number of sides it can have? Now, let's dissect this question. We know that the general formula is n times a, which equals 360, which we know that the regular polygon has an exterior angle which is greater than 50 degrees. So if we know that the angle is 50 degrees, and we know that a is the representation of degrees where n is the side, we can directly substitute this in. So we know that n of 50 equaling 360 degrees will give us a lower limit. And in this case, the upper limit will be whatever the answer above the answer we get is. Now, let's solve this. N for the sides will equal 360 divided by 50. And we're going to get n equaling 7.2. So we know a polygon cannot have 7.2 sides. So that means anything greater than 7.2, that is a natural number, such as 8, is going to be out of our range. It can be anything less than that. Now, in this case, which number falls outside this range, which is less than? Well, only one option, 8. 8 is greater than 7.2, so it will not be good enough for this question. Now, 5, 6, and 7 are all less than this number, which work because the angle of the regular polygon is greater than 50 degrees. Now, how about you guys try answering one of these questions? Now that you had a chance to look at this, let's go through this together. In the figure above, point O is the center of the circle. Line segments LM and MN are tangent to the circle at points L and N, respectively, and the segments intersect at point M as shown. If the circumference of the circle is 96, what is the length of the minor arc LN? Now, let's look through this. We know that the circumference of the circle is 96, and the minor arc is Ln. We know that the amount of degrees in a circle is 360, so everything can be related to 360, and that has to do with circumference too. It can be broken into parts based on the angle. Let's look at what the angles show within that quadrilateral. We see 60 degrees as the angle measure of M. And we know by the definition of tangent that L and N have to create 90-degree angles. Now, what does that leave O to be? Well, 120 degrees, because 360 minus 180 minus 60 equal 120 degrees. Now, what do we know about proportions? The entire circle is 360 degrees. So we can divide 120 divided by 360 to equal 1/3. So the ratio of Ln, the minor arc, is 1/3 of the entire circumference. And what is 1/3 of the entire circumference? Well, that is going to be 32. Now, some tips for answering these questions. It's important to recognize the angle operation, being put in place. Most of these have to do with circles and tangents, and just recognizing these 90-degree angles can help a lot. And others will just be simple operations. You also need to isolate the specific variables just to know what, specific information you're looking for. You're also going to need to determine the outcome, determine, the limits, as we saw in the first question, of the amount of sides, or determine the ratios in the next question. And the last thing is you need to relate your answer back to the answer choices and see which ones correspond. Next time, we'll be looking at the 5-number summary questions in the math section of the SAT.